Hi everyone, I am Mishri Patel and today I will be presenting on AWS Machine Learning Deployment, Storage, Security, Monitoring, and Managed AI Services. In this presentation, I will explain how machine learning models are deployed and managed using AWS. I will also discuss how AWS supports automation, monitoring, security, storage, and data streaming throughout the machine learning lifecycle. Finally, I will introduce several AWS managed AI services including Amazon SageMaker, Comprehend, Recognition, Lex, TextRec, Personalize, and other services that help developers build intelligent applications without creating machine learning models from scratch. After machine learning model is trained, the next step is deploying it into a production environment where it can make predictions more for real users. A production ready ML system needs several important components. First, it requires scalable infrastructure so it can handle increasing workloads. It also needs reliable interference endpoints to provide fast and accurate predictions. Automation helps streamline tasks such as model deployment and updates. Secure data access protects sensitive information, while monitoring and logging help track system performance and quick identify issues. Cost optimization ensures that cloud resources are used efficiently. Another important aspect is model drift detection, which identifies when a model's accuracy decreases because real-world data changes over time. Finally, version control and governance help manage different model versions and ensures compliance and reproducibility throughout the machine learning lifecycle. Now, AWS provides several infrastructure options for deploying machine learning application, depending on project's need. First, AWS ECS or Elastic Container Service. It is used to run containerized applications. It is fully managed service and is a good choice for teams that wants to deploy machine learning models using container without managing complex infrastructure. Next, Amazon EKS or Elastic Kubernetes Services is designed for organizations already using Kubernetes. It allows machine learning workloads to run in a scalable and highly available Kubernetes environment. Finally, AWS Lambda is a serverless computing service that runs code without requiring servers. It is ideal for event-driven tasks such as triggering machine learning predictions when new data is uploaded or automating parts of an ML workflow. Together, this services provides flexible deployment options based on application requirements and workload complexity. Now is the auto-scaling for ML workloads. Auto-scaling is an important AWS feature that automatically adjusts computing resources based on the application workload. This means that when traffic increases, AWS adds more resources to maintain fast and reliable performance. During periods of low demand, it reduces resources to avoid unnecessary cost. Auto-scaling improves application availability, helps control cloud expenses, and ensures machine learning inference workload continues running smoothly even during the traffic spike. AWS decides when to scale by monitoring different performance matrices such as CPU utilization, memory usage, the number of incoming requests, and response latency. It can also use to custom matrices collected through Amazon CloudWatch by automatically responding to changing demand. Auto-scaling makes machine learning application more reliable, efficient, and cost-effective. Amazon SageMaker provides different types of endpoints to support different machine learning workloads. First, real-time endpoints are used when predictions are needed immediately. They are ideal for low-latency applications such as fraud detection, recommendation system, and chatbots. Next, serverless inference automatically scales resources based on incoming traffic, making it cost-effective option for applications with unpredictable or occasional requests because you only pay when the endpoint is used. Asynchronous inference is designed for large requests or tasks that take longer to process, such as image or video analysis. Instead of returning results instantly, the output is delivered later after processing is complete. Finally, multi-model endpoints allow multiple machine learning models to be hosted on a single endpoint. This reduces infrastructure cost and is especially useful when individual models are accessed infrequently. Choosing the right endpoint type helps balance performance, scalability, and cost. Now, machine learning workflow automation. It helps to reduce manual effort and ensures that every stage of machine learning lifecycle is consistent and repeatable. The workflow usually begins with data processing, where the data is cleaned and prepared for training. Next, the model is trained and then evaluated to measure its performance. If the results are satisfactory, the model is registered so it can track and version before deployment. Once deployment is done, the model is continuously monitored to detect performance issues or model drift. When necessary, the model is retrained using updated data to maintain accuracy. AWS provides several tools to automate these steps. SageMaker pipeline creates end-to-end ML workflow. Apache Airflow manages and schedules the complex tasks, and AWS Step Functions coordinates different AWS services into a single workflow, and CI/CD pipelines automate testing and deployment. Together, these tools make machine learning development faster, more reliable, and easier to maintain. Now, let us see what is CI/CD in ML workflow. CI/CD stands for continuous integration and continuous development. In traditional software development, the process mainly involves testing the code, building the application, and deploying it to the production. However, machine learning workflows are more complex because they involve not only code but also data and trained models. In ML, we still test the code, but we also verify changes in the data and version the trained model artifacts to ensure everything is traceable. There are several important concerns in ML CI/CD. Dataset versioning keeps the track of data used to train a model, while model versioning allows teams to manage and compare different model releases. Matrice thresholds ensures that the new model is only deployed if it meets the required performance standards. Finally, reproducibility ensures that the same model can be recreated using the same data, code, and configuration. This practice helps make machine learning deployment reliable, consistent, and easier to manage. Now is the Amazon storage services. AWS offers several storage services to support different machine learning workloads. AWS S3 is the most commonly used storage services because it provides scalable object storage for datasets, trained model artifacts, logs, and prediction outputs. It is highly durable and is often the main storage service used throughout the ML lifecycle. AWS EBS or Elastic Block Store provides block storage that is attached directly to EC2 instances. It is ideal for applications that require low latency access such as model training on virtual machines. AWS EFS Elastic File System offers shared file storage that can be accessed by multiple compute resources at the same time, making it useful for collaborative machine learning environment. Finally, Amazon FSx provides high-performance file system designed for specialized workflow that requires very fast file access, such as high-performance computing and large-scale machine learning training. Choosing the right service helps improve performance, scalability, and cost efficiency. Many machine learning applications rely on real-time data instead of waiting for data to be collected in batches. AWS provides several streaming services to handle this. Let us see about the streaming data for machine learning. Amazon Kinesis collects and processes streaming data in real time, making it useful for applications such as system logs, website click streams, IoT devices, and event data. Amazon MSK or Managed Streaming for Apache Kafka is a fully managed Kafka services that simplifies building and managing Kafka-based streaming applications. Another service is Amazon Managed Service for Apache Flink, which provides streaming data in real time and supports advanced analytics and data transformation before the data is used by machine learning models. This streaming services enables important machine learning use cases such as fraud detection, where suspicious transaction must be identified immediately, live personalization, where recommendations are updated in real time, and IoT monitoring, where sensors data is continuously analyzed to detect issues or predict failures. Together, these AWS services make it possible to build intelligent applications that respond instantly to incoming data. Amazon SageMaker provides several built-in tools that make machine learning development faster and more efficient. One of these SageMaker Data Wrangler while simplifies data preparation and transformation by allowing users to clean, combine, and prepare datasets without intensive coding. Another important tool is SageMaker Feature Store, which stores, shares, and reuses machine learning features. This ensures consistency between the data used during model learning and data used for prediction in production. SageMaker Jumpstart helps developers accelerate machine learning projects by providing pre-built models, solution templates, and example notebooks that can be deployed quickly. Finally, SageMaker Model Monitors continuously monitors deployed models to detect problems such as data quality issues or model drift, where the model's accuracy decreases because real-time data changes over time. Together, these tools help reduce development time, improve model reliability, and simplifies the overall machine learning workflow. Once a machine learning model is deployed, it must be continuously monitored to ensure it continues to perform well over time. One common challenge is model drift, which occurs when the data or environment changes, causing the model's accuracy to decrease. There are three main types of drift. Data drift happens when the distribution of input data changes. Concept drift occurs when the relationship between the input data and the expected output changes. Prediction drift refers to changes in the model prediction patterns over time. To detect these issues early, monitoring should track several key matrices, including input data quality, prediction quality, response latency, error rates, and resource utilization. It also provides to monitor business performance matrices such as customer satisfaction or scales. To ensure the model is delivering real business value, continuous monitoring helps organizations identify problems quickly and restrain or update models before performance is significantly affected. Then is the monitoring and observability tools. They are essential for keeping machine learning system reliable and efficient after deployment. AWS CloudWatch logs collects log data from AWS services and application, making it easier to troubleshoot issues and understand how the system is performing. CloudWatch also tracks important operational matrices such as CPU usage, memory utilization, request rates, and response time. These insights help team optimize performance and choose better deployment configurations. Another useful service is AWS Cost Explorer, which tracks and analyzes cloud spending. Together, CloudWatch and Cloud Explorer help ensure that the machine learning application remain reliable, high-performing, and cost-effective. Security is a critical part of deploying machine learning application because it protects data, model applications, and underlying infrastructure. AWS provides several services to help achieve these. AWS Key Management Service (KMS) manages encryption keys that are used to encrypt sensitive data, ensuring that only authorized users can access it. AWS Secret Manager securely stores and automatically rotates sensitive information such as passwords, database credentials, and API keys, reducing the risk of security breaches. AWS Macie helps discover and protect sensitive data by identifying confidential information stored in AWS S3, such as personal or financial data. Finally, AWS Trusted Advisor provides best practice recommendations to improve security, reduce cost, increase performance, and enhance system reliability. Together, this AWS security services helps organizations build secure, compliant, and trustworthy machine learning solutions. Machine learning governance ensures that models are deployed, developed, and managed in a secure, responsible, and compliant way. One important area is access control using AWS Identity and Access Management or IAM, which ensures that only authorized users can access data and ML resources. Data should also be protected through encryption, both when it is used and stored, known as data at rest, and when it is transmitted on a network, known as data in transit. AWS Cloud Trail provides audit logs that record user and system activity, helping organizations meet security and compliance and requirement. Government also includes tracking different model versions and using approval workflow to ensure that only validated models are deployed into production. In addition, organizations should evaluate models for bias and fairness, protect user privacy, and continuously monitor deployed models to ensure they remain accurate, secure, and reliable. Together, these practices support responsible and trustworthy machine learning systems. Now is AWS Managed AI Services. It allows developers to add artificial intelligence capacities to their applications without building or training machine learning model from scratch. This makes AI development much faster and more accessible. One of the main benefits is faster development because pre-trained AI models are already available. These services Also eliminates the need to create custom models for many common tasks, saving both time and effort. Since they run on AWS managed infrastructure, they automatically provide scalability, reliability, and security. Another advantage is that they integrate easily with existing applications through simple APIs. AWS Managed AI Services supports a wide range of use cases, including text analysis, speech recognition, image and video analysis, document processing, intelligence search, and personalized recommendation. Overall, this service helps organizations quickly build the AI-powered application while reducing development complexity and cost. While building AI application on AWS, organization must decide whether to use managed AI services or develop a custom machine learning model. Managed AI services are the best choice when the task is common and already supported, such as language translation, image recognition, or document processing. They are also ideal when fast implementation is important, when there is no need to build a custom model, and when you want the AWS to handle scalability and infrastructure management. On the other hand, custom machine learning models are a better choice when the business problem is unique or requires specialized predictions. They provide greater control over the training data, algorithm, and model behavior, making them suitable for application with strict accuracy requirements or specialized user case. In summary, managed AI services offer speed and simplicity, while custom machine learning provides flexibility and greater control for complex business needs. To summarize the full certification preparation, the major area includes ML foundation, data preparation, model training, optimization, deployment, monitoring, security, and managed AI services. These areas connect together into a complete AWS machine learning workflow. Understanding how the services fits together is important for both the certification exam and real-world ML projects. Thank you so much for handling me throughout the journey of our preparation of AWS machine learning. Thank you so much.